In this video, we look at a mass attached to a spring that is stretched in the x and y directions. In the beginning, we look at the physics of the spring attached, as the mass attached to the spring. We use Python to model the movement of the mass attached to the spring and tracker to collect observation data. This video was provided to us, and we use these observation data in a spreadsheet. There are two forces acting on the spring: the gravitational force Fg and the spring force. The spring force changes while gravitational force is constant. Both forces are of course vectors. The spring force stretches in the x and y directions, and it's the difference between the equilibrium and current position. The kinetic energy is half mv squared, where v is derived from Newton's law. The potential energy is always negative, since in this case the y-axis is always negative. Here we look at a model of the observed and computed positions. You can see there's a slight difference. In this case, the y positions and y calculated and observed positions are more in agreement. We can use drag to improve the accuracy of the model positions. We use a drag vector which is added to the net force, and now you can see that the x positions are more closely related to the observed positions. Similarly, the y positions that we compute using the model are also close to the modeled, to the observed positions. When we use FNet without drag, the trajectory of the mass is just a straight line which goes up and down. When we do use drag, we get a slightly more elliptical trajectory. These are energy calculations. Kinetic energy is maximum at the x position, which is 0, and the gravitational potential energy is maximum at the highest y location, and the spring force is highest at the lowest y position. This slide shows you the gravitational force, which again is highest at the highest y position. So you can see gravitational potential energy and spring potential energy oppose each other. The frequency of increase of kinetic energy is twice the rate of the gravitational and spring potential energies. This is a plot showing you energy changes in kinetic energy, gravitational potential energy, spring potential energy, and the total energy change. The x period for the oscillations was 1.712 seconds, and the y oscillation was 1.4 seconds.